Hello, everyone. Today we're going to start talking about Chapter 8 of our textbook, SIMIO Workbook, and we're going to discuss the flow and the capacity issues in the SIMIO model. The example we have for this chapter is a DMV office problem, and this is the place where you get your permits, renew your driver license, and get your new driver license. Okay, so first we're going to talk about the flow and the capacity of the server, and then we're going to add on resources as a clerk to the server. The reason we're adding the resources to the server, these clerk is diversity trend, and we actually need to the clerks are diversely trained, so we need to use them for different stage of our process. Okay, and also we talk about once we have a multiple server and parallel server, we choose how to restrict the flow, which means we're going to form a so-called waiting rooms, and so all the applicants come into the DMV office waiting in the waiting room, and they go into the server only if the server is idle or available. And this portion we also repeat some of the concept we have the last lecture period, using so-called user-defined tokens, and define a process using this user-defined token. Okay. We review some of the concept about so-called appointment arrival and the random walk-in, and so far we're talking about so-called time variant arrival rate portion, but we also talk about if we have a so-called appointed arrival. So now let's talk about the capacity restriction of flow. So first is we talk about a typical server has 3 green line associated with these server. One in the left-hand side is so-called input buffer station. Okay. Stuff in there is supposed to be server 1, input buffer dot contents. And also we have a green line on the top is when the parts or the entity get out of the input buffer, they take possession of the resources within the server, then they start getting processed, and when during the time they get processed, they put it into this processing station. Okay, so whatever entity showed up here represent the entity currently in process. Then after the entity got processed, finished their processing, and then they join the output buffer and waiting in the output queue to be transferred out. For most of our current models so far, we don't have waiting for the output. Since the output link is readily available, we just transfer out immediately. But for other applications, such as the parts or the entity has a waiting for a vehicle or AGV or some lift truck, these type of thing, the entity will wait on the output buffer for a vehicle come here to pick it up, and so on, so forth. Okay. Talks about the capacity restriction for the resource object. Again, both resources and the server has a capacity available to be seized and released. So before the processing, we seize the resource or the server resource, server building resource. Then after processing, we release the resource within the server or external server. Very similar to the server, but no place to entitle wait and no processing time for these resources. And typically, the resources you're using as a secondary resource at a server. For example, you go into a clinic, you need to the room inside the server as a primary resource, and you see the nurses and doctors for treatment or for diagnosis, and those type of things are considered secondary resources. We place a server on the worksheet, we will usually see the server has several so-called state. One particular state is so-called starved. Starved is when the server is idle, okay, no unit or capacity being allocated for processing. The server is in the processing state, which is usually showed up in green, meaning the server is processing some entity. And the block usually show in the yellow. It was finished processing but cannot be proceed because the network is not readily available to ship the entity out yet. And the failing state of the server usually represented by a red color, and meaning the currently server is down, which is one of the main thing we're going to talk about in this chapter. The last one is off shift. Sometimes the server can have a so-called on shift, off shift, certain period of time. The server is not, this particular server is not available. It usually show light gray color. All right. Now we formally go into the section 8.1, talk about our process, the DMV Office Process. Let me go through this process workflow first. The applicants arrive to the system. It goes through a registration. There are 2 stations in here. And then go through a so-called written or visual test. Test your eyesight and giving you a written test. And after that, you have a percentage failing the written test or visual test going leave the system. If they successful pass the written test and visual test, some of the applicant goes through a driving test, which these type of applicant usually getting a new driver license. For rest of them, usually just renew their license, and after they pass the written test, they get pictured to make a new license, and then they leave. The driving test also have the successful rate or failing rate, okay? And so the failing goes to 1 sync, and the successful taking the driving test going to take a picture and get their license, then leave, okay? And the registration part depends on what type of applicant it is. It has a different registration time. And for the testing and the driving test and the picture portion, the processing time follow per distribution with a variety of parameters. So this is our initial model for 8.1. It's very similar to the one we have the last one. So we have a source arrived to the entity applicants, registration, written test, then you possible fail the test, or if you successful with the test, if you're getting a new license, you go into the driving test. All the other ones, you're just going to take a picture, getting their license, then leave. So this is a fairly straightforward model we have. Couple of detail on the applicant. Okay, the applicant travel speeds 1 meter per second, and the arrival pattern is time variant arrival pattern. So depends on different time of the day. The arrival rate are different. Okay. Also, we have 3 different type of applicant. The first time is just getting a permit, okay, which is 25% of applicants follow that portion. Second type is getting a new driver license, and they have another 25% going for that. The renew license is about 50% of the applicants going for that. And their registration time are vary as well. For each type of applicants, okay, they also have a probability of passing the test, and they also, for the applicant getting a new driver license, they have a 90% of successful rate for passing the driving test. Okay. Finally, final column, we did this before. We designate different tally statistic for each type of applicant. The applicant ID, instead of from 1 to 3, I decided to using from 0, 1, and 2, so they can be consistent with the symbol index we have. Okay. Adding tally statistic, like I would say, we're adding tally statistic using time as a unit type. And then we creating a data table, just we did it before, okay? The type of applicant, the applicant ID, the mixture of the applicant incoming, the registration time, the passing probability for the written test, and the passing probability for the driving test, and which are the tally statistic we use. And the picture below showing each type of, each column, what type of property we're using for on this table. And the short description on what type, what they being used for. And the last detail we have is once the applicants are generated from the source, we need to using a set row. And this is a very similar to the so-called table reference in the source. But today we're going to using a set row to show you how to indicate which rows on this table the applicant is incoming based on the mixture of the probability. And then we're going to assign a picture to applicants in different color. When the applicant leave the system, we're going to using a tally statistics to collect the tally statistic for each type of applicant. And the processing time value is given in here, and the capacity for each type, each work server are also given. So we have 4 different server right here. Each one has their own capacity, their own processing time. The last part we're going to talk about is the branching. Okay. From output of the server test, which is the written test, we have, possibility to pass the test, which is the table applicant passed the test. And then they have a 100 minus that number as the failing test. We're going to using as a branch, using transfer no by link weight to indicate this. Okay, from the transfer no, selecting weight is if the applicant's type is equal to 1, meaning this is a new license applicant, or to the server, directly to the picture server, if they are not equals to 1, okay? And the driving test, for the new license, they have to passing the driving test. From the output of so-called driving test, they could have a successful rate and a pass failure rate as well. So these are the things we're going to using directly the by link weight portion to determine their link weight, how they define their link weight. So this is the summary of link weight we have for different branching mechanism. Right, so this branching condition are summarized in this slide. Okay, you can refer to the slide how we're going to do this. So later on, we're going to follow this portion to set up the branching link weight. Okay. Finally, the simulation run from 8:30 a.m. to 4 p.m., 7.5 hours. we're going to show different applicant using different color and different state name of the server and the state number of the server. Okay. We're going to switch our presentation to the model right now. Okay, this is how our model looks like in the final form. We're going to start building this model from scratch in class so you can follow what I'm doing. So this is the arrival, registration, written test, and driving test, taking pictures, and we have 3 separate sync to represent different exit conditions. So I'm going to create a new model here. Okay, and we're going to call this new model in class 2. Complete empty model. First, we're going to do a source to begin with, adding a model entity right here. I'm going to call it entity applicant. Okay. And then we have 4 different servers. So I'm double click on the server. Now I can bring in 1, 2, 3, and 4 server right here. Now, zoom out a little bit. We will have 3 separate sync. Okay. Okay, so we have 3 separate sync, and the first sync is sync fail driving test. Okay, this is regular leaving, so sync leaving. This one is going to be sync failing the written test. I'm just going to do this. And the first server will be registration. Second server will be test. And the third server will be the driving test. All right. Fourth server will be the picture server, taking picture and getting. All right. So this is pretty much finished. Now we have adding the link in between. Before that, I will add a basic note right here to show you how that's going to go. And this basic note is just sidetrack some of the new license or applicant going to the driving test. Okay. So other than that, we're going to start building their path. We're going to using path multiple times, so double click on the path and start linking these together. Going that way, and this will have some link going this way, some link going down, and coming that way. We're going to align them a little bit better in a minute. All right, pretty much done. Probably just squeeze these a little bit, move this up so I can line them up together. So this looks pretty straightforward now, but we have a different length for these paths. So I'm going to highlight, this is not these, and these. Okay. We're going to change their length for that. So first go to draw to scale, set it to false. then set it to 5 meter by default. Okay. And also we can now see some of those are different, different length. Let's go back to the presentation a little bit. Probably can see. Okay. So this length is 20 meter, and 10 meters over here. Rest of them are 5 meters. So I'm going to again to come to here. All right. So this guy going back and forth to the driving test is 20 meter. Instead, from here to failing driving test, that's 10 meters. Okay. And this part is actually 0 meters. So I'm not going to do anything about that. The rest of them are 5 meter spread. And also now the inter-arrival time for the source, it follows the time-varied arrival rate. To do that, instead of doing the inter-arrival time right here, I'm going to choose a arrival rate table. So first we need to build the arrival rate table first. Let's go back to the presentation one more time and to look at the arrival table. Arrival table here, since it's 7.5 hours, actually we have a half-hour interval with a 15 grid, 15 time period, and 5-hour interval. So here we're going to create a rate table, and we call that arrival rate table. Okay, arrival rate table. So we need only 15 interval instead of 24 by default right here. And we need to have a half-hour interval. So this is 0.5 hours. And then we need to have only 15. Okay, to save time, I'm just going to copy this information from the example model, so you can fill it in manually. So we save some time in the presentation. So here we have the arrival rate tables already. Okay, go back to our facility model and choose we choose time variant arrival rate, and based on the arrival rate tables. Okay, and that's all there's to it. And also, all these server right here follow per distribution processing time. So I'm going to select those 3 server, do random per. Okay, I can do that. And the per server is fairly straightforward. The first one is for the test is per 10/14/20. So let's do that. This one is 10/14/20. So I'm going to set all these the same. And then I come back to change each one of them. Okay, each one of them. And for this driving test is minimum 15 minutes, maximum 40 minutes, most likely 25 minutes. So here we're going to change this 40 minutes, most likely 25 minutes, minimum 15 minutes is done. And the picture server is about 1 to 3 minutes, most likely 2 minutes. So I'm going to do this fairly easily. 1, 2, 3. Okay. For the registration time, it's a little bit more complicated. Now we need to, depends on which type of applicant. So here, applicant, we only have 1 applicant. Now we're going to have 3 different applicants. So the first one is green, which represents the permit. Second one, we're going to color red, represents the new driver license. And the third one is renew their license. We're going to make it purple type of thing. Okay. So we will have three different type of applicants. We're going to start doing this. Sorry, detect. And then once we've done that, and we need to start defining our data portion, create a table called table applicant. Okay, and based on the presentation, we give you a okay. The property type of each one of the column we're going to use the and the property name. So we come back to this. Create a table applicant first is going to be the string, okay, and this string we'll call the sky, so-called type of applicant, for example, or name of the applicant, and should be either using permit, getting a permit, new license, and renewal their license, okay. And the second one, I'm going to using an integer, actually, and this column we're going to call it ID. Okay. It should be 0, 1, and 2. You can set it with 1, 2, 3. It's also the same, but we need to be careful. This is how you adjust this to the picture ID you have. And the third one is the mix. Please, I'm going to give you a real number, and this we're going to call it mix. I'm going to using a very short name in the illustration tutorial, and your textbook may have a little bit different name called an applicant mix, but here this is what I'm going to use to speed up my demonstration. So 25%, 25%, and 50% for permit, new license, and renewal respectively. The next one is going to be the registration time. And for that, I need to have an expression column. We call it registration time. Okay. And very specifically, this one I'm going to specify is a time based on minutes, because this column is going to return the processing time in minutes. So this one we're going to do is random dot per 6A10, for example, for this. Okay, I'm going to copy this, move, copy this. Okay, we're going to have changing the number, which is the A10. 14. This one, and for renewal, registration time will be 578. 5, 7, and 8. All right. So we specify the processing time. We've done this before, similar before. So I'm going a little bit faster. Next one, we're going to do another real columns called pass test. Okay. So this is the probability of pass the test. For the permit, you have 90%. For the new license, you have 95%. For the renewal, you have 98%. of the time. And the next, also determine the probability of passing the driving test. So pass driving, for example, I'm going to call this column. For the permits and renewal, we don't need to do the driving test, so their probability could be 0. For the new license applicants, we're going to give them a 90% of passing probability. The last column would require you to set up certain tally. Let's go to define some new tally first. Go to define some new tally statistic. We're going to have 3. The first tally statistic is for the permit, for example. Okay. And the second one is going to be for the second one will be for the new license. And the third one is renewal. Okay, so, and each one of those should be time as their elements. It's very important since we need to collect their flow time in the system. Okay, go back to the data section. Once we define these, we're going to add in one more column, which is referring to tally statistic. And this is what we call it, tally time in system. Okay, portion. And this one's going to be referring to the permit. This one's going to refer to the new license. The last one will be the renew. All right. Let's take a look. Go back to the facility. Back here. So for these, if the customer or applicant leaves, we're going to using an add-on process to do the tally within here. For this example, we're going to show you how to using some easy add-on process. First, we're going to do is when the entity got generated, okay, we need to assign which row on this table we're going to be assigned that based on the mixture of the applicant arriving. So here we do. Before we did a table reference, and here we referring to, sorry, not this one. After we create an entity, okay, we reference to a table applicants, and then this is a reference to a table applicants, mixture, random row, okay. We've done this based on that. So we done this before. But today I'm going to show you another way to do this. Reset these. So here in the add-on process portion, after the entity got created, we create a empty process, add-on process to begin with. Well, the first we're going to do is we're going to insert a set row portion to add it to that. Also going back to other step, we're going to do sign step. So this one we're going to set table rows, correct? And this one we're going to assign picture. Okay. So for this, it's very similar to table reference in a set row. All we need to do is choose which table it is to set row and which row, and it is based on the mixture and based on the random row. So using the probability proportion to randomly generate a row and assign it to the applicant table. Then, after the row is assigned, what I need to do is model entity picture, okay, showing picture, and the value should be table rows and ID. Since we already determined which row it is, so the ID is also determined. So we're using the ID, corresponding ID, assign it as a picture index. Over here, we can using 012. Okay, all right. So this is pretty much, we can run this for, let me get it a little bit faster. You can see the different color of applicant showed up. Okay, one more thing we haven't done yet, because so far the processing time, a processed entity randomly go through each one of the branches over here. We didn't input the probability of a successful written test or failure. And also we didn't redirect if the applicant is new driver license, the new driver license, they go up here, and the rest of the entity, they don't need to. And also we haven't assigned any of the capacity for driving license as well. So let's take a look how we're going to do that. Sorry. Stop the simulation first. This is what we're going to do first. All these four, I'm going to assign them to 2 of those capacity. Only the written test is 3 for now. And the processing time for the registration, it should be follow the table. And the registration time. All right, that's the first things we need to do. The rest of the server, I believe we already have the proper processing time. Okay, now for this, either the applicant passed the written test or they fail going that way. We need to set this guys to be, instead of the shortest path, they follow by link weight. The link weight for passing, which is over here, is defined by table passing test probability. So here is the way, is fairly simple. What we can do is we do table applicants and pass test here. I'm going to copy this for now. All right. And then this part will be the opposite of a passing test, and will be 100 minus that passing probability. Okay. So this is what we've done over here. This part is also, instead of going shortest path, we're going passing by weight. So only the applicant who's applying a new driver license going to the driving test. So the link weight will be very easy to determine. If table parts ID equals to 1, which is going to going up to the driving test. So for this part is the opposite of that, which is not equals to 1. So if either permit or is either renew license, we're going to go directly to the picture section. The next things we have for the new driver license applicants, either they can fail the driving test or they success the driving test, which going down to take a picture and leave. So here, what we have also, okay, be careful, this guy needs to be, output node will be by link weight. And down there, the link pass number 6, the link weight will be table applicants and pass the driving test. as my probability, which is 90%. We can directly type 90, but here is what we show you. And this will be actually 100 minus 90. Okay. Finally, what we need to do over here is trying to get a tally statistic set up. So let's do that. Really simple. So only want to calculate this part. I'm going to show you a add-on. Okay. So when the applicant entering the sync, we're going to do a enter. Okay. For now, I'm going to do a tally statistics over here. So I'm going to tally so-called time and system tally. Okay. So what we do is basically referring to one of the tally in this column for different type of applicants. So since we already set the role for them, get to this tally. I'm going to using table applicant time in the tally time in system. Expression will be, we've done this before many times, time in system. Okay, so based on which row it is, it referring to individual tally statistic to collect the information. So let's take a look how we're going to run this. So now you should see only the red part entity should be able to go up to the driving test, and that verifies the branches are working. And we're going to fast forward to the end, look at the result. Okay, we have the 3 tally statistic in this model in class 2, and their average and maximum, minima, and we can adjust their number into minutes. In this case, we can see at the very end the sync. Okay, regular customer, we have about 200 come into this leaving part, and we have 7 coming through the fail the driving test. We have about 13 going to leave the system without passing the driving test, written test. Again, the starting time should be, actually readjust right here, should be 8:30. I'm sorry. This is 8:30 a.m. Okay, to 7.5 hours. So it's ending with, okay, ending with the 4 p.m. actually. So this concludes 8.1 and 8.1. We'll come back for 8.2 in the rest of them.